Hello everyone, welcome to the first day of product rule. Before we actually jump into the product rule, I would like to do a little warm up on the power rule that we did the other day. So please go ahead and write these down, pause the video, try them, and push play when you are ready to check your answers. Okay, go ahead and check your answers. A couple things I want to point out over here. So when I multiplied -2 times a half, that became -1. And then again, you decrease the exponent by 1, so -2 minus 1 is -3. And if you notice in the radical here, I first rewrote it as a fractional exponent, x to the 1/5. Multiply in front, 1/5 minus 1 is -4/5. Again, decreasing it by 1. Alright, so let's actually get into the product rule here. So another shortcut for finding derivatives. Here is the formal definition for finding the product rule. The derivative of the product of two differential functions is given by this. Okay, so what exactly does this mean? So if I have a first term times a second term, or a polynomial, in this case it's represented by a function times a function, first function times a second function. You take first times the derivative of the second plus second times derivative of the first. So the first part times the derivative of the second part plus second times the derivative of the first. So let me go ahead and write that down. So first times the derivative of the second plus second times the derivative of the first. Okay. So let's try this. Okay, and we're actually going to do this problem in two different ways. If we were going to do the power rule, which we did some examples like this when we were working with the power rule, we would first have to FOIL. So let's think about this. We're going to first do the power rule. FOIL. Okay, use some of our algebra skills here. So 3x to the 6th minus 6x plus 3x to the 5th minus 6. We don't have any like terms there, so we can go ahead and go right to using our power rule, finding the derivative, multiply, decrease your exponent by 1. Okay. And then a constant would be 0. Well, let's see how this differs when we do the product rule. So we actually have two functions here. So this is my first, this is my second. So when I take the derivative, I have first, I don't change anything at all to the first function or the first term, times the derivative of the second. Well, the derivative of the second, again, I have power rule here. So I bring down the 5 and subtract the exponent by 1. Derivative of my constant is simply 0. Plus the second derivative of the first. Derivative of the first, so this would simply just be 3. And then again, derivative of this constant would be 0. Now they obviously look different, so if I wanted to simplify to see if they actually match, I can go ahead and distribute. Let's go ahead and just check this. So we have 15x to the 5th plus 15x to the 4th plus 3x to the 5th minus 6. And you can see when we combine these terms, we will get exactly 18x to the 5th. It's written in a little bit different order, but I'll go ahead and write it as we have it above. We get exactly the same thing. So it really truly doesn't matter which rule you use here. I'm actually okay when you leave your answer in this form. There will be points in time where we definitely need to simplify the derivative. While we're learning this process, we don't necessarily need to do that for every single problem, and we'll talk about that. I do have to say the book typically does simplify, so you're looking at answers more like what we had to do down here when you had to keep going. Okay, we'll talk about that a little bit more in class. But let's go ahead and practice this product rule just a little bit more. Okay, much more cumbersome to FOIL this problem, so it might be a little bit easier to use the product rule versus the power rule. So let's go ahead and jump into this. So we find the derivative here. So again, first times derivative of the second. So I got to take derivative of each of those individual terms using my power rule. Plus, now this is going to be a little lengthy, so I'm going to go ahead and write it below here. Second times the derivative of the first. Again, so again, I'm applying the product rule, the power rule for each of these terms. I apologize, that got erased. Let me go ahead and fill that in. Okay. All right, let's take a look at another example here. All right, so what's a little bit different about this one? Well, it looks like we have a fraction. However, when we have integer in the denominator, we actually should be able to rewrite this problem by pulling out that fraction. So I actually have a 1 out in front of that. So I can pull out the 1/10 times quantity x cubed plus 2x squared. So now I have a first term and a second term, so I can apply my product rule. So if we take a look over here, again, first, so that's my fraction of 1/10 times derivative of the second. So again, applying the power rule to each of those individual terms, plus second times derivative of the first. Well, what's derivative of a 10th? Well, it's just a constant, just a fraction, so that would be 0. So I would go ahead and clean this up because this whole term over here is going to be just 0. So it would simply be 1/10 times the quantity of 3x squared plus 4x. Okay, let's try another one. I would like you to go ahead and pause this. We're finding the slope of the tangent line here, but I want you to find the derivative first. And then once you find the derivative, push play, check your answer, and then we'll continue along and find the slope of the tangent line at, to the function at x equals 0. Okay, so using the product rule, it's that first step that I just did here, first times derivative of the second, plus second times derivative of the first, and I went ahead and simplified it. Again, you didn't necessarily need to do it, but it'll be a little bit easier when we actually then try to find the slope of the tangent line at x equals 0. Okay, so remember, what does the derivative tell us? It tells us the slope at any point in time along the graph of the original function. So if I'm trying to find the slope at x equals 0, I simply then plug in 0 for x into my derivative, and we find that slope to be 31. Alright, so let's take a step back here and think about again, what is the product rule? Okay, so if I'm trying to find the derivative given h of x equals f of x times g of x. Okay, so this goes back to our formal definition of derivative. So I take the first times the derivative of the second. So again, our derivative is with that prime notation, plus second times the derivative of the first. Okay, so we're going to apply that definition to a chart. Now you might need to pause this so you can actually write this chart down. Okay, so I'm going to move it down so you can see this entire chart. Go ahead and pause if you need to, and then push play when you're ready to resume, because we're going to find h prime of 0, h prime of 1, and h prime of 2. Okay, so let's first start with h prime of 0. Well, really what's happening here is we're letting 0 replace x. So if we're trying to find h prime of 0, we need to find f of 0 times the derivative, or g prime of 0, plus g of 0 times f prime of 0. So using our chart, a little bit, f of 0, so here's f. When x is 0, my value is 3. Times, okay, let's find our derivative of g. Here it is. When we're finding g of 0, again, that's this first row here, so that value would be 2. Plus g of 0, so g of 0 would be a value of 4. Plus f prime of 0 would be 5. So that's going to be 6 plus 20, which gives us 6. Okay, so if we follow the exact same model to do h prime of 1, so again, it'd be h prime of 1, and we're going to plug it into this right up here. So it'd be f of 1 times g prime of 1 plus, and again if you need to, sorry, I have to keep kind of moving up, g of 1 times f prime of 1. And again, we're going to use our table and look that up. So f of 1, so now I'm looking here, f of 1 has a value of 2. G prime of 1 would be a value of 3. G of 1 would be 1. And f prime of 1 would be 2. So 6 plus 2, so that's going to give us 8. And go ahead and pause. I'd like you to do the last one, h prime of 2, and then push play when you're ready to check your answer. Okay, so answer is 31 for the h prime of 2. All right, so this concludes the product rule.